Questions 19 through 23 are some good ones to go through. So let's go through them. So the normal curve is this, 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 and this. Okay, so like that. That's what's considered normal. So okay, so number 19 is actually the hardest question. Loop ACDI. So if you look at this, here's ACDI. I think I said that wrong. Okay, so what is this? Okay, what's going on here? Okay, what's different is this point right here. Okay, it didn't happen till here. So what's different is afterload. You could also call it maybe diastolic. I'm not going to spell diastolic pressure. Diastolic pressure. Okay, so let's so now that we've figured that out, let's look at the answer choices. Okay, so hemorrhage, what's that going to do? That's a decrease in volume. So what's going to happen is as we're going up, we're not going to make it all the way to A. We're not going to have an end diastolic volume as high as we should. So that's not a right answer. A positive inotropic agent, that would be increasing contractility. No, this is increasing afterload. We're not looking for an increase in contractility. Contractility would have to do with landing on a new PIP line, and I don't think we are on a new PIP line. So let's see, an increase in intrathoracic pressure. This would be the Valsalva maneuver, where you're blowing out a birthday cake. I mean, you're really, think about that, increasing the intrathoracic pressure. That's going to that is going to actually, and this is kind of hard to understand, but it's going to decrease the afterload because the left ventricle is being compressed by the muscles that are pushing air out of the lung. So the left ventricle is not going to have to push as hard. And the opposite of the Valsalva maneuver, where you breathe in and hold it, that actually will increase afterload. So that's actually a really good thing to remember for testing. Okay, so the answer is C, administration of an alpha adrenergic receptor agonist. Okay, so alpha adrenergic receptor agonist. What they left out of this question was that this is probably an alpha 1. Okay, remember alpha 1s are all about vasoconstriction. Okay, so it's an adrenergic receptor. Do you remember the opposite of an alpha 1? It's actually a beta 2, and that should remind you of asthma and albuterol and stuff like that, which is always on board exams. Okay, number 20. ABFG shows the effect of. Okay, so let's look at ABFG. I've marked this up quite a bit, but ABFG. So ABFG. Here we are. We're going like this. Okay, so what changed? Okay, here is our old peak isovolumic pressure line. Here's our new peak isovolumic pressure line. So the only way you can change that line is a change in contractility. Okay, so by definition, this is the answer, a positive inotropic agent. Okay, so opening of the aortic valve occurs at, and so if you just look here, and I've really marked it up, so I'm going to take some stuff off of it. Positive opening of the aortic valve, it's right, let's see, it's going to be C. Okay, so just by definition, it's going to be C. Boom. Point A, D is not, and E, D would be when it's closing. E is, where is E? I think that's E. So this is when the aortic valve is closing. So these wouldn't be right either. Okay. An increase in venous return will increase which of the following points? Okay, so venous return. Okay, so venous return, that's going to increase end diastolic volume. So remember, that's end diastolic volume. I'm going to write it over here. EDV. You can also think of end diastolic pressure, and then you can also think of central venous pressure. That's actually an index. It's not, it's proportional to where you're going to end up here, but it's not, it's not a wonderful measure of it, but you can measure central venous pressure and get an idea of what preload is going to be, also known as end diastolic volume, end diastolic pressure. Okay, so so increasing venous return will increase, and the only one that it's going to increase, and this is a bad question, because it's just a bad question, but what's going to happen is you're going to get further up here. So the correct answer is A. Weird question. Anyway, hopefully the most important thing is that you understand the principle. But okay, isovolumic relaxation. Okay, relaxation. So we're decreasing pressure. So where's pressure? Pressure's over here, so we're decreasing it. And then we look at this word iso. Iso means same, volumic, so same volume. So we're decreasing pressure at the same volume, and that's going to take place on one of these lines. Any one of these would be fine because we're decreasing pressure at the same volume. So let's see if any of those lines are there. And it looks like we've got DI. So DI is there, so that would be the answer. I hope that makes sense.